We had a very good tutorial in the morning. For those of you who were to the tutorial, there's not a lot new information. Right? This is more an introduction into the Eclipse Gyrex project. So we use, I'm talking a little bit about the domain where we use Gyrex, where we created a project. Talk a little bit about the server applications, the Eclipse RT components that are used in Gyrex, and also a little bit about how to build those applications. Actually, there's a demo in the end, but we only have a short slot, so I won't give the demo here, but I'm available on the conference the whole week. So if you have any questions or want to see the demo, just ping me afterwards or any time this week, and I can give you a nice little demo. So we use Gyrex to build server applications. And by server applications, I'm talking about applications that we develop for either for ourselves or for clients that run in a data center or in multiple data centers. Usually they are e-commerce applications running on the servers, serving online shops, integrating with other systems, SAP, for example, all that kind of stuff that happens in the e-commerce world. So we have lots of high traffic. We have many data centers. We have different technologies that we use, devices that connect to the applications. And we love the modular development capabilities that OSGi gives us, right? And we also need those modular development capabilities because some of the applications, we run them and offer them to our clients as a service. So kind of software as a service solution. So we develop individual modules for clients, and then we deploy them to a server dynamically at runtime without interrupting other clients. And of course, because of that, because we run the stuff ourselves, we also focus on making it easy to set up a cluster to operate the system. Okay, so Gyrex is, I'd like to describe it as an application stack built out of Eclipse RT technologies. There are a lot of great projects in Eclipse RT, right? But when we started putting them together into a technology stack that works on the server, we actually found ourselves writing glue code, integration code, for example, for integrating Jetty with that make Jetty a little bit more dynamic. There is the OSGi HTTP service, which also has a Jetty-backed implementation, but it is very limited in terms of the capabilities, what you can do with the OSGi HTTP service. There's a new spec ongoing to enhance that service, and we really hope that the work going into this will offer more flexibilities in the future. But meanwhile, we started looking at Eclipse Link. We started looking at Gemini for using concepts like JPA, Java persistence, in the OSGi world. And we found ourselves writing code, and then we thought, hey, we don't like to write that code multiple times. We just let's create an Eclipse project, put the code on there, and reuse it in the projects that we do. And hopefully, that's our intention. We actually find somebody else in the community that is interested in this project, because we think that work is valuable to a lot of people doing pure OSGi development, right? We're not trying to compete with Java Enterprise applications, because that's really not our domain space. We do pure OSGi applications, and we love that. And that's also the focus in this project. So on the bottom of everything runs Equinox. Equinox is the OSGi runtime implementation. The reference implementation, it's kind of the basement, the foundation of Eclipse RT. Everything is meant to run on Equinox, but we found that, for example, a lot of those Eclipse RT projects, they run perfectly without Equinox. Jetty, for example. Jetty runs standalone in a lot of environments. And also Eclipse Link runs alone in a lot of environments. And now we looked at, okay, so how, when we put that together, we actually wanted to cluster, build multiple nodes, multiple framework installations, running Jetty, running Eclipse Link, and connect them together. So we created, I come later to that, we created a bit of clustering component that we put on top of that. Jetty is a really nice servlet container. It can run standalone, but it's also very, very convenient to embed it into your application. Google App Engine did so. They actually embed Jetty into the core of the Google App Engine to run servlets, right? And they integrated very, very deep with Jetty to secure the environment in terms of provide monitoring on the servlets that are executed, because Jetty has a lot of APIs. Currently, Jetty is working on version 9, and they are rebuilding the NIO stack, rewriting the NIO stack for all this communications so that they can adopt to newer protocols in the future. They're really, really good at adopting the new protocols. Jetty already has support for Google Speedy. And so if you deploy Jetty today, Speedy is enabled out of the box in Gyrex. Eclipse Link is, historically comes from Oracle TopLink. It was a move of open sourcing Oracle TopLink as the reference implementation for JPA, AGB. But it grow far beyond, so it's not just JPA anymore. There's also a JAX-B implementation. There's support for OSGi, for Spring, or Olga ADF in Eclipse Link. And we took that together with other projects in our stack, and then we thought, hey, let's wrap that into a project, and that is Gyrex. So Gyrex is basically Equinox with a bunch of other interesting Eclipse RT projects. We have a built-in clustering component, a web-based administration UI that we wrote using Eclipse Wrap, which is also an interesting runtime project. The Eclipse source people, they have a booth where they're showing wrap technology on multiple devices. So that's very interesting. If you're writing your UIs in Java, it gets rendered as nice HTML web applications, or on the iPhone or iPad, using native widgets actually. We also have built-in support for multi-tenancy. That's because of our software as a service requirement. So when you live in an OSGi world, you have things like OSGi services, for example, right? You have a payment service, for example. And a payment service integrates with a payment gateway and implements some like credit card authorization, capturing, etc. And for one particular, in a multi-tenant system, you're working with many different payment gateways at once, right? So for one particular client, you use that gateway implementation, or for another client, you use a different service implementation. So we created a little logic, context logic to actually have the code, keep the code clean from this multi-tenancy decisions, but just letting the code ask for an OSGi service and have the multi-tenancy engine making the decision which service gets injected into the code, whether it be the payment service for that payment provider or for another one, so that every tenant can actually choose a different implementation. We also have a couple of enhancements in there that we found very convenient when working with Equinox in a runtime or in a server environment. So you need a bit of more logging into it, and a cluster provisioning UI and all that kind of stuff. So we write those things in Gyrex and continuously enhance the project with new features that we think are worthwhile to integrate. So a little bit more about the features. I already mentioned the term application stack. That's how I like to describe it. It's really a pure Equinox OSGi runtime. There's no other integration or logic wrapped around. We do cluster configuration using Apache Zookeeper. So we settled on Apache Zookeeper after investigating a few options because we like the project a lot. We like the API. We like the scalability that it offers. Zookeeper is known to allow to scale to clusters of thousands of machines and coordinating all these machines. And it gives us neat options. For example, we implemented a cluster-aware job scheduling mechanism. So you can write Eclipse Jobs and just push them into a queue. The queue is persisted in Zookeeper. And then we have a set of worker nodes that just pulling the jobs from the queue and start working on them, right? So if you're in a cloud-like scenario where you have increasing workloads, for example, during Christmas time, right? Or you can just fire up a bunch of Amazon nodes, EC2 instances, and make them workers so they start executing the jobs. And once that is done, you just shut down the instances so the cluster can shrink and grow at runtime. We have a mechanism for automated deployment using P2. Luckily, it worked this morning in the tutorial. And we also use the concept of node roles to actually establish a meaning, give the nodes like a meaning what they are. For example, if you have 10 nodes in a cluster, you can say, hey, 4 are web servers, which basically run Jetty and the web applications, and the other 6 are just worker servers for background processing, right? And you can change those assignment as runtime. If you, for example, see increasingly web traffic, you can just promote 2 worker servers to web servers at runtime. That's a picture of the components that we have. So again, on the bottom, everything is Equinox, the OSGi reference implementation. Then we have what we call contextual runtime. This basically is the multi-tenancy extension. And within that, we created the concept of HTTP applications. So you write an HTTP application, servlets, JAX-RS resources, or whatever. You write it once. And then at runtime, you mount it multiple times. You create the instances dynamically on particular URLs. Right? For example, you can have a subdomain mapping, and that really comes down so that each tenant gets its own instance of the application. So the servlet is running multiple times in the same container, but totally isolated for each tenant. So you can actually keep tenant data within the servlet, which is specific to a tenant without intercepting or disturbing other application instances. The cloud component is all the bundles that we created for integrating with Zookeeper, providing integration with the Eclipse Preferences API. The Eclipse Preference API is based on OSGi preferences. I don't know who already works with OSGi preferences, but we also created a new scope that allows you to persist those preferences into Zookeeper. The idea is that you basically make some configuration in the UI and that it's available immediately on all the nodes. That's very interesting feature because you no longer have to take care about synchronizing configuration information. It's just persisted in Zookeeper, and every node has immediate access to the data. And Zookeeper scales very well in terms of read traffic. So we have the processing component, that's the Eclipse Jobs API that we distribute among worker nodes. The permissioning component that uses P2 to actually install software at runtime into a cluster. Right? So I can set up a cluster with just a naked Gyrex installation, a bare Gyrex installation with nothing on top of it. And then I just go into the UI, define the P2 repositories to fetch the bundles from, define a package of what should be installed, which bundles, which features, click on provision, and then every node in a cluster, one by one, goes through the repository, install the bundles, and restarts itself if necessary. If not, it just activates the bundles, and releases. So this process is serialized one by one, so that effectively if you pushing out a bad release, destroying a node, we immediately stop the whole process so that an operator can investigate what's going on. And in the monitoring section, we have some integration with logging frameworks out there. So Java has more logging frameworks than UI toolkits. We use OSGi to integrate with all of them. So we collect all the logging APIs, Java Commons logging, Log4j, SLF4j, Java utils logging, even Java utils logging. And then we route that into Logback so that you have a central place where you configure the log files, the log locations, the appenders, the log levels, and everything gets propagated to all the APIs and all the third party using the same logging output that you configure. You just don't have to care, it's all set up. We support the debug and tracing capabilities in Equinox so that you can enable debug and tracing at runtime using console commands. And we collect server metrics automatically. We added some new metrics to Jetty and other parts of the system. In the admin section, I already mentioned the console, so we have some extensions to the Equinox console. The Equinox console is now available using SSH. Thanks to the Virgo and SAP folks, we actually created or integrated the Equinox console with Apache Go shell. And using that, you can connect to the console in Equinox using SSH and issuing all the commands. But we also created a nice web UI that we recently redesigned. Previously, we were using the wrap workbench, the whole Eclipse workbench with views, perspective, and all kind of stuff. And we found that it is a very heavy model for web application development, so we dropped that and created a new web UI that's using the lightweight wrap application concept using direct SWT development. That's actually a picture, well, a little bit abstract, but how we set up a typical cluster at runtime. So we have, in the center, we have the Zookeeper nodes. So during development, you actually don't need a Zookeeper server running because we include the Zookeeper server binaries in our download, and then we just start an embedded Zookeeper server in development mode. You can run a Gyrex server in different modes, development and production, and this basically influences the defaults, the settings, the services that get started. One is, of course, optimized for development, and production is optimized for security, right? So in production mode, you don't have, for example, we don't start the embedded Zookeeper, we don't start Jetty, we don't open any ports, right? It really has to be enabled by a server operator. Then we have a bunch of nodes that communicate through the Zookeeper cluster with each other. We have P2 repositories where we fetch, where we deploy new software updates, and then every node in the cluster picks them up. Actually, we have many different P2 repositories. We have a staging repository for a staging or a test system, right? And once that is verified, everything is properly, then we just promote the staging repository to a production repository, and the production service just pick on a particular repository. It's also possible to set up P2 mirrors in each data center so that the nodes in the data center just pick the pieces from the local P2 mirror. In front of so the web nodes, these layers are the web nodes. They typically run Jetty engine, and we use Jersey. We integrate with Jersey for providing a REST API using JAX-RS services. JAX-RS is a standard for developing REST web services in Java. It's very easy. You just create a pojo, put in a few annotations, and then it instantiates your code and injects the dependencies. Yep, and then we have the many native applications. We have traditional web applications connected to that API. And also the new devices or Internet of Things. Okay, so the next version that we're currently working on is 1.2. It's out to be in March around EclipseCon. We just finished migrating the last missing pieces to the new admin UI. We also added a few new capabilities. Some are still in the pipeline, for example, logging configuration. The full Gyrex support is now officially part of Gyrex. Previously, it was a separate application add-on that you had to install. Now it's included. We looking at reworking the job history storage options because right now it's stored together with a job configuration in Zookeeper, but we actually found out that in production it causes a lot of unnecessary write traffic to Zookeeper, so we are reducing that to have more flexible storage options, for example, into a database or whatever. And we're also working on some Equinox DS improvements that we have planned to make it better to enable logging at runtime to investigate the system better. For the future, for long-term future, we still have items on our plate with a better integration with OSGi standards. For example, the OSGi configuration admin, Tomcat integration. And there's also a blog to be out. I got a question this morning with Virgo. So it is possible to provision Gyrex on top of Virgo Nano because they have the P2 support, right? However, the next thing that we need to look at, and I just ran into Glyn this morning, Glyn Normanton, who's the Virgo project lead. We need to figure out what's the best options for integration points with Virgo, right? So we have all these nice clustering capabilities, and it would be really good if we just don't install Gyrex on top of Virgo, but really integrate it with Virgo so that you can configure parts of Virgo with using the Gyrex admin UI, for example. Or other way around, throw away our admin UI, integrate with the Virgo admin UI. That's also a possible option that needs to be discussed. Okay, time is up. There are a few links for you. If you have any questions or want to see the demo, just come to me during EclipseCon or write on our forum or send me an email, hit me on Twitter. Thanks a lot for your attention.